What is forward bias in diodes and transistors? Imagine you're controlling water flow through a pipe. If you open the valve in the right direction, water flows easily. If you turn it the wrong way, flow stops. That's similar to what happens in semiconductor devices when they are forward biased. In electronics, forward bias is a condition where a voltage is applied across a PN junction in a way that allows current to pass through easily. For diodes, this means connecting the positive terminal of the power supply to the P-type material, called the anode, and the negative terminal to the N-type material, called the cathode. This setup opposes the natural electric field at the junction. Inside the diode, there's a region called the depletion zone, which acts like a barrier preventing current flow. When you apply forward bias, the external voltage reduces the width of this depletion zone. As it shrinks, charge carriers like electrons and holes gain enough energy to cross the junction. Once they cross, they recombine in the neutral regions, creating a steady flow of current. The voltage needed to make this happen is called the forward voltage or threshold voltage. For silicon diodes, this is usually about 0.7 volts, while for germanium diodes, it's around 0.3 volts. When the diode is forward biased with enough voltage, electrons from the N-type side move toward the P-type side, and holes from the P-type move toward the N-type. This movement results in current flow, and the voltage across the diode stays roughly constant over a wide range of currents. That's why diodes are used for voltage regulation and switching. Now, transistors also need forward biasing to work correctly. In a bipolar junction transistor, or BJT, the base emitter junction must be forward biased. When you apply a positive voltage to the base relative to the emitter, it allows current to flow from the emitter into the base. This injection of charge carriers turns the transistor on and enables it to amplify signals or act as a switch. In field effect transistors, or FETs, forward biasing of the gate-source junction controls whether current flows between the drain and source terminals. Applying the right voltage to the gate creates an electric field that opens or closes a channel, controlling the current flow. In practical applications, forward biasing is what makes diodes useful for converting alternating current to direct current, known as rectification. Light-emitting diodes, or LEDs, emit light when forward biased because the energy from the voltage excites electrons. When these electrons recombine with holes, photons are released as light. In transistors, forward biasing sets the operating point, or Q point, which determines whether the device amplifies signals linearly or switches rapidly between on and off states. Without forward bias, these devices wouldn't conduct or amplify as needed. Understanding forward bias helps in designing circuits for power supplies, signal processing, and switching. It's the key to controlling how current flows through diodes and transistors, making them essential components in all kinds of electronic systems.